the final part of Booklet F. This is part 3, looking at the final 4 things: transformations of graphs, bit of proportion, direct and inverse proportion, some nth term and sequences, and then ending with some trial and improvement. Just pick it out on these 4, okay? I haven't said this before, but just keep an eye on what you need to be revising for what papers, particularly the last 2 here. They won't be in non-calculator, so you can leave these 2 alone until paper 2, whereas the other 2 things we'll do in this video, I guess could be in either. Okay, so revise those well. We go into page 17, which is here, and I'll talk you through some of the basic transformations of graphs. Now, in part 1 of this video and part 2, we looked at different types of graphs, and as a reminder, there are 3 examples here. A straight line graph, y equals mx plus c. In fact, the one that we've got here is just y equals x, so a gradient of 1, because there's the number 1 before the x, and an intercept of 0 because there's no number at the end. Okay. Then we've got y equals x squared, 1 bend, okay, and y equals x cubed, 2 bends. And all of these have a y-intercept of 0 because there are no loose numbers at the end, like plus something or minus something. Now, generally in this type of question, what they're going to say is, look, we've drawn a graph, but we're going to call it y equals f of x, something like this. Right, it doesn't have to be f, sorry. It could be, but basically, right, what it means, right, don't overthink it. It means we have drawn something to do with x. F stands for function, a function of x. So we might have drawn a quadratic or a cubic or an exponential or a reciprocal. We have drawn a graph to do with x, and we want you to do something to it. Okay. Now, hopefully you can see these. Now, the ones that we're going to be looking at are, if they ask you to draw y equals minus f of x, we're going to reflect what they've drawn in the x-axis. If they ask you to draw y equals 4 times or 3 times or a number times f of x, then that thing is going to get steeper or narrower. So if you look at my hands, okay, say it was quite open like that, to make it steeper, they'd come in like that, okay. What doesn't change is where my wrists meet here. That stays in the same place, but these kind of come in on themselves. The opposite of that is a fraction before the fx, like a half or a third, where rather than getting steeper, they get wider. So they start like that and move outwards. Sorry about that bad demonstration there. F of x plus a number moves the graph up. F of x minus a number moves the graph down. And then the weird one, if it, instead of putting that plus or minus number outside the bracket, you put it in with the x, so x plus 4x minus 4. Instead of moving up or down, then the graph will move left or right. And the important word here that you've got to bear in mind is it'll do the opposite to what you think. In other words, if it's f of, in brackets, x plus 4, it would be 4 to the left. That's not what we would expect, but it is. Okay, but if it was x minus 4, it'll be 4 to the right. Okay. Really quickly, because we don't have long in this video. So, here's y equals f of x. Now, we actually happen to know what they've drawn here. They've drawn y equals x squared, but they're calling it f of x. So, the first one, I can see that what's happened to it is it's moved up. So, I'm looking for f of x plus something. That, up 4, must be. This one, it hasn't moved up, down, left, or right, but it's become steeper, narrower, it's moved in. So, I'm looking for the f of x being times by a number. This one, 2fx. This one hasn't moved position, but there's a reflection. It's been flipped upside down, so I'm looking for minus fx. Minus f of x. This one, again, it's the same shape. It's not steep or narrow, not been reflected, but it looks like it's moved over to the right. So I'm looking for, and this is the awkward one, f of, and in bracket, x. Now, and it's the opposite to what I would expect. So x minus something. So f of x minus 3, meaning 3 to the right. And then the last one, rather than being steeper, is less steep or wider. So I'm looking for multiplied by a fraction. This one. Okay. The type of thing you might get in the exam is, we've drawn y equals f of x. Can you draw f of x minus 2? And you'd have to realise the minus 2 in the brackets means 2 to the right. Therefore, it will look identical. That's quite hard to make it look identical, but in a different place, okay? But the important one is that number will have moved from 0 over to 2. Any other numbers on there are irrelevant. This one, we've drawn y equals f of x. Can you draw y equals minus f of x? That's a reflection. Plus 3. The plus 3 not in the bracket means up 3. So what I've done is I've started by drawing the reflection in blue, so I've drawn minus f of x in blue. Then I've shifted it up 3, so instead of cutting there at 0, it cuts up here, but it's kind of like, for want of a better word, it's parallel, it's the same kind of shape as this, but just everything's up 3. That's moved up 3, that's moved up 3, that's moved up 3. Every part of it has moved up 3. Now, some harder examples. Here we go. This is a minus f of x. It's written slightly wrong there, actually. I prefer that the minus should be before the f. So anything above the line is reflected below the line. Anything below is reflected above. Hopefully you can see that. This one here. We're asked to draw f of, again you'll have to read this, but this is f of x. We're asked to draw f of x minus 3 in the bracket. The minus 3 in the bracket is right 3. So, they've given me 3 coordinates, so I need to look at what happens to all 3. Well, it's the x value that's going to change because we're moving over. So instead of being 5 naught, that'll move over 3 to 8 naught. That'll move over 3 to 2 naught. That'll move over 3, so from 2 7, it'll still be 7 up. But instead of going from 2, it'll move across to 5 7. So you can see that. So the whole thing has moved over 3 to the right. Now, a bit of a dodgy one. This should have been on the same pages because it belongs with the question on the next page. However, what we're going to do is we're going to do different transformations to this graph, and we've got to decide what has been done. So if we just kind of pick out some key features here, it goes up, bends down, bends up. So it's a cubic. Not important to this question though. We just got to call it y equals f of x, okay? And the point there is minus 2, 2, and 2 minus 2. Let's have a look. Now I've written what all these mean here, okay? But let's have a look at them one by one. Now, this one, okay, it's hard to see without having the last page in front of me, but if we remember on the last one, if you can see that compared to the other 4 here, the other 4 all come up, down, up, up, down, up, up, down, up. This one comes down, up, down. It's actually been flipped. That point was up there originally and that was down there. They've both flipped. So this is your reflection. So I'm looking for minus f of x, which is that. This one's been done for you. Now we have a look at the third one down. This one looks like the thing has been shifted down. This point was up there, it's now been shifted. Everything's come down, shifted down 2. So I'm looking for f of x minus 2, which is that one. This one, it looks like everything has shifted across to the right. That point was there, and that point was there, and the whole thing has moved over. So I'm looking for f of x, and in the bracket, a minus 2, the opposite of what I think, which is that. And I hope you can see that. And then the last one, that point hasn't moved, but everything has kind of become steeper. So I'm looking for that positive number before f of x, which is there. And I've actually written on what I expect all of these to do. Make sure hopefully that makes sense to you. So that would be down to, left to, reflection, steeper, up to, wider, and right to. Okay. This one. They're saying we have drawn x squared plus 2. So we're not using f of x now. They're actually telling me the actual graph they've drawn is x squared plus 2. In other words, they've already moved it up 2. They've taken the x squared and they've moved it up 2, hence why it's cut in there rather than there. Okay. Our job is to draw x minus 4 in brackets. The fact that the number is in the bracket with the x means it's a right or left movement, and the fact that it's minus 4 means that it's right 4. In this case, I can ignore the plus 2 because that move has already been done. All I've got to do is shift this over 4. So instead of being 0 and up 2, it'll go to 4 and up 2. And then, as long as I pass through that point, and it looks kind of similar, yeah, okay. Another one a little bit like that, saying we have already drawn y equals minus x squared. Can you draw x squared? The opposite of what I'd normally expect. What they're saying is I've already drawn the reflection. What did it look like before the reflection? So let me reflect that. And then they're saying, right, now have a go at 4x squared. So they're times in that graph, that x squared graph, by 4. And we know that if you times by a number, it makes the thing steeper. So this point doesn't change, but it comes in steeper and leaves steeper. Again, I'm going to turn these on the sides. I'm not going to talk through these, but if you want to pause on there, do it now, check it, alright with that. Look, notice everything moves up 3 there, not just there, but those points. I saw a couple of you, when we did this in class, try and connect from there to there to there. No, these points move up as well, so we're coming in. Right, you get the idea. And then these ones as well. A movement, left 3, and a reflection there. Okay, proportion. Alright, the first one. Given that G is proportional to H squared, so here, let's recap what we do here. The proportional sign is kind of like the little fish sign, so G is proportional to H squared. We swap the proportion sign for an equals, and when we do that, we introduce a K. Alright, so G equals K H squared. We then look at the values we're given. We're told that when G is 1, H is 3. So we can swap G for 1, and we can swap H squared for 3 squared. Okay, 3 squared being 9. So 1 equals K times 9, which I'm going to write as 9K. So K is equal to 1 divided by that 9. So K is 1 over 9. I then go back, it's kind of working in a circle here. I go back to this, right? But instead of writing G equals KH squared, the whole point of what I've done here is to work out what K actually is. And K we know is 1 over 9. So I've written G equals 1 over 9 H squared. Now I can get other pairs of G and H knowing what I know. So this one says, okay, now that you know this, what is G when H is 2? So G is equal to 1 over 9 H squared, but if H is 2, 1 over 9 2 squared. 2 squared is 4. 1 over 9 times 4 is 4 over 9. Another one to look at. Okay, this time we're proportional to the square root of x. Change that to an equals, introduce a K, same thing. Put in the values that you know, y and x. Alright, so y is 30 when x is 36. Y is 30 when x is 36. That's allowed me to work out that k is 5. Back to the beginning. But instead of y equals k square root of x, I know that k is 5 now. So it's 5 square root of x. And again, have a little look at my workings here. You can then work out what y is when x is 49 and what x is when y is 40 with a little bit of algebra. Make sure you're okay with that. Plan to do the next one if you don't mind. Okay, because it's a more wordy one. But I'm looking, again, as long as I see that word proportion, direct proportion, inverse proportion, blah, blah, then I know what I'm doing. Catherine is measuring the force between a pair of magnets in a physics laboratory. It is known that the force between the magnets is inversely proportional to the square of the distance d. Okay, if it was directly proportional, it would be that. Okay, but inversely just means 1 over. So in this case, it's proportional to 1 over d squared, or inversely proportional. Again though, I swap that for an equals and I introduce a k. So instead of 1 over d squared, it's k over d squared. Now I'm looking for a pair of values. Catherine measures the force to be 4 newtons when the distance between the magnets is 10 meters. The force is 4 when the distance is 10. Keeping the same layout as I have, I change the F for a 4 and the D for a 10. 10 squared is 100. Instead of dividing by this 100, I'm going to move it up as a times. 4 times 100 means that K is 400. Back to this, but swap the K for 400. That's the expression. That would be the part A in the other questions we've done, but this is all chucked in together, so I'm looking for the part B. And the part B, right, if you think of this as part A and part B then says, okay, what is the distance D when the force is 100? So I'm going to swap that for 100 and work out what D is. I'll do that over here if you don't mind. So the force is 100, F is 100, which is equal to 400 divided by d squared. Just put 100 in instead of F. Instead of dividing by d squared, take that up as a times. 100 times d squared is equal to that, and then I can bring the 100 down as a divide in its place. Which is that? So d squared is 400 divided by 100, which is 4. And to find d, I take the squared over as a square root, and the square root of 4 means that that is 2. And another then inverse proportion one here, y is inversely proportional to x, so 1 over x. Again, swap that for an equals, introduce a k, put the two values in you know instead of y and x to find out what k is. In this case, k is 12. back to the beginning, but replace the k with what we know it to be 12. There's my answer to part A, y equals 12 over x. There's an expression for y in terms of x, okay? And then replace the x with 0.25, and we'll get the y is 48. Replace the y with 60. Have a look at the algebra I've done there, and you find that replace y with a fifth, and have a look at the algebra then, you find that x is 60, other way around to what I said. Okay, moving on. Before we attack the last two topics, the two calculator topics, although nth term doesn't really need to be a calculator topic, you know, it could easily be done without a calculator, but just appears that it's more normal in a calculator paper based on the last few years anyway. But trial and improvement is a cert. You'll definitely need a calculator for that. But before we do, let's just quickly remind ourselves of a few things. Hopefully this will help you. So if I had something like 3, 12, 21, 30, a sequence that's going up in nines, okay? Up in 9, so plus 9, plus 9, plus 9, okay? Then basically what this is the 9 times table, okay? So the nth term rule would be 9n, okay? So this is what the nth term does, is it tells us any number in a sequence. So based on this, I would expect the first number to be 9 times 1, 9, and 9 times 2, 18, then 9 times 3, and so on. But it's not, because even though it's the 9 times table, it's starting in the wrong place, okay? So the other bit that belongs with this then is you go back a number to what I referred to it in class as the 0th term. First, second, third, fourth term, but in reverse, fourth, third, second, first, and then before the first you've got the 0th term. So if I was coming down in nines, this number would be minus 6, and you plonk that on the end. So what we've got here, actually what this sequence is the 9 times table, take away 6, alright? 9 times 1 is 9, take away 6 is 3, 9 times 2 is 18, take away 6 is 12, and so on. Another example, 14, 17, 20, 23, it's going up in 3s, 3n, and that number there would be this time positive, so 3n plus 11. Final example on this, okay, so maybe coming down 20, 14, 8, 2, okay, coming down in 6s, so minus 6, minus 6, minus 6, so it's minus 6n, and that number there, well, I'm going in the other direction, so if I add on 6, that would be 26. Okay, so they are linear sequences going up by the same amount each time, or down by the same amount each time, and that's how you find the nth term. Okay, another type of question is where they give you the nth term and they ask you to find the sequence. So I could, they tend to go with n squared ones on these, so something like n squared take away 3. Okay, the first term when n equals 1, right, would be 1 squared take away 3. 1 times 1 is 1, take away 3 is minus 2. The second term in this sequence would be 2 squared take away 3, 4 take away 3, which is 1. The third term would be 3 squared take away 3, 9 take away 3, which is 6. And so on the fourth term. And we could just keep going, okay? We won't. But one thing you would, if I write these out in order, one thing we do notice here, okay, is that they go up by different amounts each time. The jump from minus 2 to 1 is plus 3. From 1 to 6 is plus 5. From 6 to 13 is plus 7. That would be plus 9, and so on. Now, it's more rare than this, okay? But they could ask you for the nth term of a sequence that goes up by a different amount each time. Something like this one. Okay, so let's just have a look how we would approach it. Now, the reason it jumps in values like add 3, add 5, add 7, and so on is because of this n squared. That's what causes this to happen. In fact, if you see anything that does that kind of thing, so I'll take 3, 6, 11, 18. Now this is going up. Add 3, add 5, add 7. So I can't use the kind of rule I was using for those linear sequences, something n plus or minus something. Here I've got to come up with something else. So if ever you see this where there's a differing difference, it's going up by different amounts each time, start by asking yourself the question, what would the n squared sequence look like? Okay, the first term would be 1 squared, 1 times 1, 2 times 2, 3 times 3, 4 times 4, etc. So if it were the n squared sequence, it would be this, but my sequence is 3, 6, 11, 18. Then look, what I have to do to these numbers to make these numbers. How can I make 1 to 3, 4 to 6, 9 to 11, 16 to 18? All of my numbers in my sequence are 2 more than what the n squared sequence would be. So my sequence is n squared plus 2. Hopefully that makes sense. I might try one more and then I'll show you the ones in the booklet. Okay, let's go for the one here. Okay, minus 2, 1, 6, 13. Right, minus 2, 1, 6, 13. Again, plus 3, plus 5, plus 7. It's not one of these linear ones. It's going up by different amounts each time. I start with n squared. But if it were n squared, it would be 1, 4, 9, 16. 1 times 1, 2 times 2, 3 times 3, 4 times 4. But my sequence is minus 2, 1, 6 and 13. What can you tell me about these numbers compared to these numbers? How do I get from there to there? Obviously, all of these are 3 less than their counterparts there. Counterparts, I should say. So my sequence is n squared minus 3. Okay? Final thing to say about here. When I worked out what this sequence was, so I did 1 squared minus 3, 2 squared minus 3, and so on, it might pick a random one and go, oh, by the way, what's the 20th term in this sequence? So when n is 20, and you do 20 squared, take away 3. 20 times 20 is 400, take away 3 is 397. So if you know that, the nth term formula, you can work out absolutely any sequence, but the most normal thing is to work out maybe the first 3 or 4. Okay, back into the book, and we were just about to pick up page 24. I shouldn't need to say too much now. Okay, this sequence is going up in 7s, and the 0th term would be minus 2, 7n minus 2. Find the 20th term of this, swap n for 20, work it out. And more linear sequences, hit pause at any point. Okay. Find the first 3 terms, so swap n for 1, swap n for 2, and swap n for 3. Again, it's more the same down the bottom. Find the first 3 terms. There. Over to page 25. Some more examples of linear sequences. One that's going up in 7s, and the number at the 0th term would be minus 1. One that's going down in 6s, minus 6n, and the 0th term would be 32. And one that's going up in 5s, and the 0th term, the number there, would be plus 3, which is what we've got on the end there. And we end these then with 2 of these sequences that are not going up by the same amount each time. And the one that I haven't done, which is this bottom one, 3, 6, 11, add 3, add 5, add 7, add 9. So to me, I know it's something to do with n squared, but n squared would be 1, 4, 9, 16, 25. All the numbers in this sequence are 2 more than that. So this sequence here is n squared plus 2. Here they've decided to draw the sequence rather than write it out, but all I've done is I've counted the squares because I find it easier to work with numbers. So I've worked out that the sequence here is 2 tiles, 5 tiles, 10, 17. Spotted that it's going up by different amounts each time. Yet again, it's that common one, 3, 5, 7, 9. So I've written out what n squared would be, 1, 4, 9, 16. But I'm looking for 2, 5, 10, and 17. All of these numbers are 1 more than what they would be here. So this sequence is n squared plus 1. Actually, you could do it visually here though, right? And you might be able to spot, look, in pattern 4, what I've got is a 4 by 4 square with 1 extra, n squared plus 1. In pattern 3, I've got a 3 by 3 with 1 extra, 3 squared plus 1. 2 squared plus 1, 1 squared plus 1. Therefore, in the nth pattern, there would be n squared plus 1. So you can do it that way. I much prefer counting things and actually just kind of doing them as number sequences rather than picture sequences. Okay, we're on to the final bit, which is trial and improvement. Now, I have done 3 of these. I've deliberately left the first one to do with you. Okay, my understanding is that they're going towards possibly putting a number in front. It's normally a cubic, something x cubed, but putting a number in front of the x cubed, and this is the only one I found with a number there. So I want to show you kind of how we kind of avoid making mistakes if there's 2x cubed or 3x cubed or something like it, okay? We're going to use trial and improvement, so I'm going to need my trusty Casio. I'll show you how to use that in a second. And the answer to 2x cubed minus 3x minus 17 lies between 2 and 3. Use the method of trial and improvement to find the solution correct to 1 decimal place. So we've got to use trial and improvement. We've got to guess what the answer is, and if we get it wrong, we improve our guess until we get as close as we can. Okay, if the lies between 2 and 3, the most logical place to start would be halfway, 2.5. This is how I would like you to set them out, please. We're going to try x is 2.5. So, anywhere I see an x, I'm going to replace it with 2.5. So instead of 2x cubed, it'll be 2. And I like to, when I put things, substitute things in, I like to put them in brackets, 2.5 cubed. Minus 3, lots of, in brackets, 2.5, minus 17. And I'm looking for the answer 0. Now, the calculator will get this right if you type it in like this, but just to pick out, okay, based on bid mass, if you've got 2x cubed, what the calculator will do is it needs to do that first. It needs to cube that before. It's not 2 times that and then cube it. It's that cubed times by 2, and that's very, very different. However, if you're using your calculator to plug it all in, you shouldn't make a mistake. So you might not be able to see the face here, but what I'm going to put is 2, open bracket, 2.5, close bracket. There's a cube button here somewhere there. Okay. Minus 3, open bracket, 2.5, close bracket, minus 17. So I've typed it in as I've written it there, equals 6.75. The answer I was looking for was 0. I've got the answer 6.75. That is bigger than 0, so I just write on the end there, this answer is too big. Okay, if 2.5 gives me an answer too big, let's reduce it. Let's go down to, maybe not 2.4, let's drop a couple and go to 2.3. I write out exactly the same thing, but this time I'm subbing 2.3 and trying again. Back to my calculator. 2, open brackets, 2.3. Close brackets cubed, minus 3 lots of 2.3, close brackets, minus 17 is, ooh, getting close, 0.434. It's very, very close to 0, but it's still a little bit above 0. It's too big. We're so close, I'm tempted to just go down 1 now to x equals 2.2. 2 lots of 2.2 cubed, minus 3 lots of 2.2, minus 17. Don't know I needed a bracket there, I certainly don't. Equals, let's go. 2 lots of 2.2, close brackets cubed, minus 3 lots of 2.2, close brackets, minus 17, equals minus 2.304. Now this is, we've gone below 0 now, so our answer is too small. This is where I hate, I'm not such a fan of these. To me, it's quite clear which one of these answers to 1 decimal place has given me the closest to 0. It's this one. 0.434 is much closer to 0, which is what I was wanting, than minus 2.304 is. So I already know that the answer is this. X equals 2.3 is the closest I can get to 1 decimal place, which is what they want. So don't go more accurate than 1 decimal place, that's all they require. However, you will not get full marks for leaving, even though it's a correct answer, for saying X is 2.3. You've got to prove it. So what we are saying is, when I tried 2.3, okay, you don't have to draw this in the exam, but let me just kind of show you. When we put in 2.3, my answer was too big, TB, too big, suggesting it's smaller than that. When I used 2.2, my answer was too small, suggesting the answer. So the answer lies somewhere in between there. So what I do is I do a check, and I hit the number, even though it's a 2 decimal place. We're not trying it as an option, we're using it as a check. We're going to use the number in the middle, which is 2.25. But instead of writing try, what I'm now doing is I'm going to check x equals 2.25. Same thing. See what we get. Back to the calculator. 2 lots of 2.25 cubed minus 3 lots of 2.25 minus 17 equals, and it is minus 0.96. I'm going to give a few decimal places here, 969 to 3 decimal places. Less than 0, too small. Now, what does that mean? What we are saying is that in the middle here, when we've tried this middle, it is too small. Okay, therefore my answer must be bigger than 2.25, because 2.25 is giving me an answer too small, so it must be this side of it. Therefore my answer must be nearer to 2.3 than to 2.2, this side of the check. So once you've written that check, you can then go, actually now I have proved that x must be 2.3 to 1 decimal place, okay, which we knew before we did the check, but we've kind of proved it. Okay, there's a couple more for you to try if you would like to over that page and the next. I'll just give you the answers to these. I'm not going to go through them. Maybe I'll just mention this one. I tell you what kind of infuriates me as well is with this one. I tried 3.5 in the middle and I got an answer too small, so I went bigger. 3.7 still too small, so I went bigger. 3.8 too big. So I knew 3.7 was too small, 3.8 was too big. I did my check, which was in the middle, 3.75. And my check came out to be too big, suggesting that my answer is this side of my check and is 3.7. Okay, I would have known it anyway because I'm looking for the answer 0, and minus 1.747 is closer to 0 than 2.272 is. So I already knew that was the answer, but I've proved it by checking the number in the middle. What can sometimes happen, and I want you to avoid, is this. The answer to the check was closer than either of these were. When I did the check at 3.75, I got the answer 0.234, which is pretty close to 0. However, I'm not allowed to take 3.75 as an answer. Why? Because it's asking me for an answer to 1 decimal place, not 2. This check cannot be an answer. It is literally there to prove, is the answer bigger than 3.75, in which case it's 3.8, or is it less than 3.75, which it is in this case, in which case it's 3.7. Do the back page, I would, and hit pause in here maybe, and then come back and check your solutions. If you've done that, here they are. For this one I get 4.3 too small, 4.4 too big, check in the middle 4.35 too big, therefore 4.3. And with this one, very, very similar. 4.3 again, same numbers, became too small, and 4.4 too big. Did a check in the middle, 4.35. Again, the check too big, so again, 4.3. One other thing I'll say before I disappear off this video is with this one, it's slightly different to the others because it says equals 91 instead of equals 0. Totally up to you. I've gone with it, okay, so I've just kind of tried to get 91 as my answer and said whether my answer is bigger than 91 or less smaller than 91. However, you can move the 91 over as minus 91 and leave it equal to 0 and just take 91 off all of these and try and get 0 if you prefer that. Leave that with you. And that's it. The end of my videos, the end of Booklet F Part 3. Best of luck with all your revision. I will see you for revision sessions in the lead up to the exams. Try not to miss them if you can, and we'll go through anything that you've had problems with. Leave comments beneath any video of anything you want me to re-explain or you don't think I've done a good enough job or glossed over, and I'll do them. Or take photos of any questions you're struggling with and put them on those comments, and I'll answer them in videos again. All the best, Year 11.